Hello, my little mathematicians. Today I'm going to help you go through the midterm study guide. Now remember that all of this is review, so I greatly recommend that you go through, try some, pause the video, try them, then unpause it and come back and check to see how you did periodically, okay? Because you want to see if you could do this yourself. And feel free to fast forward, rewind, check the answer key. If you got them right, just fast forward to the ones that you need help with. All right, let's go ahead and get started. So for the first one, it wants you to recognize which ones of these numbers are whole, integer, and rational. Okay, so if you remember, okay, I'm going to do it actually on this sticky note. Okay, all the numbers that we deal with for sixth grade are rational. Okay, and within that, they break down into other groups. Okay, you have integers and wholes. Okay, now next year, you're going to introduce naturals. So you start counting with 1, 2, 3. Then each time you go up a step, you just add something. Okay, so now you start counting with 0, 1, 2, 3, 4, 5, 6, 7, etc. Okay, so all of these are included in this set. It's just that this one added a 0. Now for integer, it's the same thing. It's all of these included, except it adds one more thing. So it's all the negative whole numbers as well. Okay. And then it's still, of course, 0, 1, 2, 3, 4, 5, 6, 7, 8, da, 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 da. Now, when you go up the step to rational is all of these things plus the things in between, like, negative 3.5, negative 3, negative 2, negative 2.25, negative 1, and I don't know, like 0.75. Okay. So it includes all of the fractions and decimals within here. Okay. So again, like negative 3.5, negative 3, negative 1, 0. Remember, it's the positive fractions as well. So like 0.3 or 1/2 and 1, etc. So if something were a whole number, it's whole and integer and rational because 0 is included in all these sets. 1 is included in all these sets. But if it's a negative number, negatives aren't included in whole numbers. So a negative whole number would be just an integer and rational. And then rational is all of the positive and negative, any number that can be written as a fraction. So that includes whole numbers because a whole number can just be put over 1 and made into a fraction. So as long as something can be written as a fraction or, like basically if the decimal ends, it can be written as a fraction, is rational. And then, yes, there is going to be something called irrational that comes later, and then real numbers. Okay, but for right now, this is it. So remember, if it's one of these, it's that and everything above it. So just start with 0, 1, 2, 3, and so on, and then add in the negatives, then add in the numbers in between. So if I use that to reference, okay, negative, no, but it's an integer, which means it's also rational. Okay, positive, and again, this is 8th grade. Okay, so for a whole number, yes, so that means it's whole, integer, and rational. It's all of them. Okay, 4.5, no, only rational. 6/3. Now, the problem is a lot of you guys probably put that this was a fraction, so you jump to rational. But 6 divided by 3 is 2. If you were to see 2, what's 2? It's whole, integer, and rational. Okay, and then 0 is also whole, integer, and rational. All right, hopefully you did pretty well on those. If not, just type in CUDA. And then identifying rational numbers, and that way that'll give you some extra practice with that. Okay, so convert the fractions to decimals. There's 2 ways that you can do this. The first way that sometimes works, that's easy, is if you can make that denominator become a power of 10. Like if this denominator can become 10 or 100, you can go straight from that to a decimal. Because look, let's see. 5 times what is 10? 2. So do the same thing on top. 2 times 2 is 4. 4/10 is equivalent to 2/5 because if it were to reduce, it's 2/5. But once you have a base of 10, you know that 4/10 is 0.4. pretty nice, right? Now, the problem is that sometimes that doesn't always work. Like if it's 8, you can't make 8 become a power of 10. So what you do is you take the numerator and divide it by the denominator. Remember, top dog goes in the house, okay? Or in and out, in and out. That's what a hamburger is all about. So inside the house, outside the house. Okay, now 8 can't go into 5. So you add a decimal and a 0 because 5.0 is the same thing as 5. But now I can do 8 into 50. And 8 goes into 50 6 times. When you subtract that, you get 2. Always make sure that your remainder is less than what you're dividing by. If it's bigger than what you're dividing by, erase this. You need to pick something bigger. Okay, keep going. 8 goes into 20 2 times. And 8 times 2 is 16. Subtract that, you get 4. Bring down the next number, and 8 goes into 40 5 times. Subtract that, you get 0. So it ended at 0.625. So 5/8 is equivalent to 0.625, and 2/5 is equivalent to 0.4. This one also would have worked if you did 2 divided by 5, because 5 can't go into 2. So add a decimal and a 0. 5 goes into 20 4 times. So see, this way always works, but if you can make the power of 10 for the denominator, it's a lot easier. Excuse me. Okay, now we're going the other way, and we're going to convert these decimals to fractions. So if I convert these decimals to fractions, this is my numerator, and then whatever place it's in, that's the denominator. Okay, that's in the tens place, so it's 5/10. The whole number stays a whole number, and then that's in the tens place, so I put it there. Okay, or I think how many numbers are off the decimal, that's how many zeros there are. So for instance, if you had 1.45, let's just throw that out there, that would be 1 and 45 what? Hundredths. Okay. Now there's only one thing that I forgot. We always want to make sure we have them fully reduced. So this can reduce by 5 and you get 1/2. So 0.5 is the same as 1/2. 3/10 can't reduce anymore. So you're done. This one can divide by 5. So you get 1 and 9/20, and that can't reduce anymore. So you're done. Okay. But I just wanted to throw that out there that you, if there's more than one number after the decimal, then you just put another 0. So like, for instance, let's say you had 1.999. Okay. That would be 1 and 999 over 1,000 because there's 3 numbers after the decimal. So there's 3 zeros here, or that last 9 is in the, thousandths place, and this 5 is in the hundredths place, and this 3 is in the tenths place, and that 5 is in the tenths place. So you just put the number after the decimal, whatever place value it's in, and then reduce it if needed. Okay, those weren't actually part of it. The next set they want you to do is to compare using an inequality sign. The directions might say compare using an inequality. Those are inequalities. Okay. First off, always look if you can simplify things and you want them to be alike. So like if one's a decimal, one's a fraction, have them both fractions or both decimals, and so on. Nothing to simplify here. What's greater? 4 is greater. So 2 is less than 4. Remember, your great big open end is always facing the bigger number. Okay, here I need to first take the absolute value of 3 is 3, and the absolute value of -3 is also 3, because absolute value is how far is that number from 0. Well, -3 is 3 away from 0, and 3 is also 3 away from 0. So these are both equal to each other. Okay, the absolute value of 6 is 6, and nothing's happening here, so that's still a -6, and positive numbers are always bigger than negative numbers. This one, nothing's happening. Here, the absolute value of 2 is 2, and then that negative out in front is saying, hey, what's the opposite of that? A negative. Now, if the negative was inside, then yes, the absolute value of -2 is 2, but it's not inside, it's outside, so it's saying what's the opposite of 2? A negative. Okay. These are equal to each other. All right, hopefully you're doing pretty well so far. Remember, always pause the video, try them yourself, and then unpause it and come back. Okay, which number line below shows 2 and 1/5? Well, first of all, I need to know exactly what 1/5 is as a decimal. So take 1, divide it by 5, it can't go in, so I'm going to add a decimal and a 0, and 5 goes into 10 twice. So it ends right there. So that means that 1/5 is 0.2 and 2 is just a 2. So 2.2. Okay, so this is like 2.5. No. This is 2.1. No. That is 2.2. Yes. Okay, my next one says write in order from greatest to least. Okay. First off, I need to put them all as decimals, and it looks like the furthest one out is 2 numbers after the decimal, so let's have them all go 2 numbers out, or actually 3 numbers out. Okay. And negative 1.240 and negative 1.570. And then that one, 2/5. If you do 2 divided by 5, that goes in 4 times. So you get 0.4. And then 0.300. Okay. So the first thing is I always like to double check what it's saying. And I underline greatest twice and least once so that it shows me big to small. It's just a visual reminder. So we know that the positives are going to come first. So what's the biggest positive that you see? The 400 and 300. And this is why I say it's important to put the same number of decimals after all of them, because otherwise you would have seen this as just 0.4 and thought that like 0.245 and 0.25 were bigger. This is like 0.400. So this is the biggest, then 0.300, then the 0.250, then 0.245. Okay, now the negatives are where it gets tricky. Remember that the less money you owe, the closer you are to becoming positive, right? So I do this little number line sketch to help me reference. And -2 is actually smaller than -1 because -1 is closer to 0 and closer to becoming positive, or I'd rather owe $1 than owe $2. So since I'm going biggest in value to smallest in value, you start this end, go this way. I want the smaller of the negatives. So where's the smaller of the negatives that I see? It's this -1.240. Then -1.300, and then finally -1.570. Okay, and then they always want it rewritten how it was originally given to you. So that 0.400 was the 2/5. Okay, and then the 0.3 was 0.300 was that last 0.3. Okay. And then the 0.250 was this one, 0.25 initially. And the 0.245 was that second one that was given to me just like that. Okay, and then 0.1240 was right there. And that was just given to me initially as -1.3, and that was given to me as -1.57. Okay, so again, I kind of do this in 3 steps. The first step, I write them all so that they all have the same number of decimals after each other, so that then it's easier for me to line them up in the proper order. And pay attention to the directions if it goes greatest to least or least to greatest. Then rewrite them how they were originally presented to you. Before I move on to this next one, those of you that are watching the video get a little bonus trick here. Let's say that I had a trick question here. And number 5, let's say that it said 2 and 2/9. Okay. So 2 and 2/9 is 2.2 repeating, which is like 2.22222 in your calculator. Okay, so is that 2.2? Is that the same thing? No, because 2.2 is 1/5, and I said 2/9. So obviously those aren't the same thing, right? 2.2 repeating is like 22 cents if you were to think about it, versus 2.2n. So I can maybe add a zero there. And so that would be like $2.20, which is different than $2.22, because here, when it's repeating, the next number is a 2. And here, when it doesn't repeat, when it ends, the next number would be a 0. Now, why am I doing this? Those of you that are watching the video, you may have a little bit of a hint on the other people, because is 2.2 the same as this? No. So if it asked me for 2 and 2/9, it would be 2.22. So this would probably be 2.25. So this would be 2.20 exactly. This would be 2.30. So this would be halfway. So this is like 20, 25, 30. And so then 2.22 would probably be somewhere about there. Something like that might happen on your midterm. So those of you that are watching the video, you got a little bit of an advantage. Okay. The next one says find the opposite of -6. What's the opposite of a negative? A positive. This one says find the GCF of 12 and 15. So what can go into both? 3 can. And 3 times what is 12? 4. 3 times what is 15? 5. Are you done? Can anything go into 4 and 5? No. So there's your GCF. It's the greatest number that can go into both 12 and 15. Okay, the next thing they want us to do is to find the LCM. Okay, well, to find the LCM, I'm going to start with the same step. I'm going to ask myself, what can go into both 8 and 16? 2 can. 2 times what is 8? 4. 2 times what is 16? 8. Am I done? No, something can go into 4 and 8. Okay, you could put a 4 here, sure, but let's say you put a 2. 2 times what is 4? 2. 2 times what is 8? 4. And 2 can go into both of those. 2 times 1 is 2, and 2 times 2 is 4. Nothing can go into both 1 and 2 other than 1. So if they asked for the GCF, it would be these numbers along the side, 2 times 2 times 2, which is 8. However, it didn't ask for the GCF. It asked for the LCM. So I'm going to multiply all those numbers of 2 times 2 times 2 times 1 times 2. Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 1 is 8, and 8 times 2 is 16. So 16 is the smallest number that both 8 and 16 can multiply to become. That's what LCM stands for. Now, some of you guys are like, oh my gosh, I missed it because I didn't start with a 2. I put a 4. That's fine. You just had a smaller ladder, because 4 times 2 is 8, and 4 times 4 is 16, and you could still keep going. 2 can go into both. 2 times 1 is 2, and 2 times 2 is 4. When I go to do this, if you'd found the GCF, 4 times 2 is 8, but if you're doing LCM, 4 times 2 is 8, 8 times 1 is 8, 8 times 2 is 16. Okay? Even if you started with an 8, you just would have had a really short tree. And 8 times 1 is 8, 8 times 2 is 16, or the GCF would be right there of 8. Okay. Our next one is to find the sum. When you are adding fractions, I strongly recommend that you rewrite them vertically. Okay. And then when you're adding or subtracting, you need to find a common denominator. So what can both 4 and 16 become? Well, they can both become 16. I like to look at the bigger number, 16. I ask myself, can 4 become 16? Yes, then that's the common denominator. If not, I go 16 times 2 and ask myself if 4 can become 16. Or sorry. Okay, I'd do 16 times 2, which is 32. And then I'd ask myself, can 4 become 32? And then 32 would be my common denominator if it wasn't 16. Sorry, I got distracted by an email that came in. Then, if for some reason you don't like doing it that way in your head, of looking at the bigger number and using multiples of the bigger number to see if the smaller number can become that. You could also do the LCM, because LCM is the smallest thing that both numbers can multiply to become. So 4 can go into both. It goes in once to 4 and 4 times to 16, right? 4 times 1 is 4. 4 times 4 is 16. 4 times 1 is 4, and 4 times 4 is 16. So there's my LCM. Okay, now I'm going to use that to create equivalent fractions. 16 times what is 16? 1. So do the same thing on top. 13 times 1 is 13. Here, 4 times what is 16? 4. So do the same thing on top. 1 times 4 is 4. So 4/16 reduces to 1/4, and this already had a denominator 16, so I just kept the fraction the same. Now I keep the denominator the same and I add the numerators. 4 and 13 make 17. Don't forget to add the whole numbers. 5 and 2 make 7. Don't forget, if it can be reduced, reduce it, or if it's improper, I need to know what this is. Well, 17 divided by 16, 16 goes into 17 once. When you subtract that, you get 1, so you put your remainder over what you divided by. So 1 and 1/16 is the same as 17/16. So then I add the whole numbers. 7 and 1 make 8, and tack on the 1/16. And there you go. Okay, again, if you're subtracting, still please rewrite them vertically and try to find a common denominator. So what can 9 and 2 both become? Well, look at the bigger number 9. Can 2 become 9? No. So 9 times 2 is 18. Can 2 become 18? Yes, then they both can become 18. Okay, or you could do the latter to find them. Okay, now I want to create equivalent fractions with the common denominator of 18. So 2 times what is 18? 9. Do the same thing on top. 1 times 9 is 9. Remember, if I'm ever going too fast, you can always play, like hit the bottom where the speed is and slow me down, or you can speed me up. Okay, 9 times what is 18? 2. So do the same thing on top. 2 times 2 is 4. Can you take 9 from 4? No, you can't. So I need to borrow from the whole number and add 1 as a fraction. Now, a fraction of 1 is the same number over itself. So I'm going to pick whatever this denominator is over itself, so that way it already has a common denominator and I can combine these numerators. So 18 plus 4 is 22. Now I have a big enough numerator to take 9 away from. And 22 minus 9 is 13 over 18. And 8 minus 6 is 2. Always double check, can this reduce? It can't, so you're done. Okay, now again, only when you're adding and subtracting do you need to rewrite them vertically. The trick to multiplying and dividing is that if they're mixed numbers, I have to change them to impropers. I can't multiply the mixed numbers as is. You cannot do 1/7 times 1/6 and 3 times 1 and try to add. It doesn't work. Okay, so to change a mixed number to an improper, you keep the denominators the same, and then you take the denominator, multiply it with the whole number, and add the numerator. So 7 times 3 is 21, plus 1 is 22. 6 times 1 is 6, plus 1 is 7. Now you look, you could multiply across and get, what's 22 times 7? 14 plus 1, 15, 154 over 42. Or what I think is easier, because that sounds like a horrendous thing, right? 154 over 42 to try to deal with that math and reduce it. I like to do what's called cross canceling or cross reducing. So what number can go into 7? 7 can. So 7 divided by 7 is 1. 7 divided by 7 is 1. What can go into 22 and 6? 2 can. So 22 divided by 2 is 11, and 6 divided by 2 is 3. Now I have much smaller numbers when I multiply across. 11 times 1 is 11, and 1 times 3 is 3. Rather than going 42 into 154, I'm doing 3 into 11. Much nicer and easier. 3 goes into 11 3 times, and that's 9. Subtract that, you get a remainder of 2. So you put your remainder over what I divided by of 3. So 11 over 3 is 3 2/3. You would have gotten the same thing if you had done this. You probably just would have had to reduce it down. Okay. When you're dividing, it starts off the same way as multiplying with fractions. I need to change my mixed numbers to impropers. So 20 plus 1 is 21, 24, 25, 26, 27. The only thing that's different is instead of diving right in, if it's dividing, I don't know how to divide fractions. I only know how to multiply. So I'm going to change it to a multiplying problem where I go keep, change, flip. I keep the first fraction the same. I change division to multiplication, and I flip that second fraction. Okay. Now, some of you guys are like, why do we do that? Essentially, you already are doing that. Like, let's think when you do 4 divided by 2, you're technically doing 4 times 1/2. Because if this was 4 over 1 and 2 over 1, if these were like fractions, so to speak, I keep this as 4 over 1. I change division to multiplication, and I flip 2 over 1 to be 1/2. And then when you multiply across, you have 4 over 2, and 4 divided by 2 is 2. So like you're always have been doing that. You just don't think about it when they're whole numbers. Just something to throw out there. Okay. Now that we have this multiplication fraction, I look to see if there's anything that can cross cancel. And what can go into 4 and 8? 4 can. 8 divided by 4 is 2. 4 divided by 4 is 1. What can go into 21 and 27? 3 can. So 21 divided by 3 is 7. And 27 divided by 3 is 9. Now that they're smaller numbers, multiply across. 7 times 2 is 14. And 1 times 9 is 9. Take the top, divide it by the bottom because it's improper. If it was 9/14, you wouldn't have to do this. But because it's improper, I need to change it to a mixed number. 9 goes into 14 once. When you subtract that, you have a remainder of 5. So I put my remainder over what I divided by. So 14 over 9 is the same as 1 and 5/9. It can't reduce, so you're done. Okay, next thing. Says a computer processor costs $84. In 3 months, it'll cost 3/4 of its current price. Remember, when you have a fraction followed by the word of some other number, it means you multiply the fraction times whatever that number is. You're like, there's no number there. Well, of its current price. What is its current price? It's $84. Okay. And to make a whole number a fraction, just put it over 1. Can 4 go into 84? Yes, it can. So let's cross cancel. And 8 divided by 4 is 2, and 4 divided by 4 is 1, so that's 21. 4 divided by 4 is 1. Now multiply on top across, which is 21 times 3, so that's 63. And on bottom, 1 times 1 is 1. 63 over 1 is just 63. So if it's 3/4 of its current price, how much is it going to be? It's going to be only $63. Okay, my next one says Peyton is making chocolate cakes that need 1 1/3 cups of chocolate for each cake. How many cakes can she make with 11 cups of chocolate? Okay, if you need to, sometimes reading it again helps. How many cakes can she make with 11 cups? And you're trying to see how many of those she can put inside or how many she can make from it. So this is a dividing problem. So I always think, how much do I have? And then I divide that by how much is needed for each one. So I have 11 cups, and I need to divide it by 1 1/3, the amount that is needed for each one. So this, just put it over 1. Voila, it's a fraction. This, change it from a mixed number to an improper by going 3 times 1 is 3, plus 1 is 4. And then because it's dividing, keep, change, flip. Sadly, those cannot cross cancel, so multiply across. You have 33 over 4. So you take the top divided by the bottom. Remember, in and out, inside the house, outside the house. 4 goes into 33 8 times. When you subtract that, you get 1. So you put your remainder over what you divided by. So if it's 1 1/3 cups needed for each one, and she has 11 cups, she can make 8 1/4 of a cake. If it asked you how many whole cakes she can make, if it just said how many, you could write it as 8 1/4. But if they asked, like, she only wants to make whole cakes, is that 8 or 9? 8. She only has enough to make 8 cakes. Even if this was like 8 3/4, which is 8.75, I know like rounding rules would say, oh, round up to 9. She can only make 8 3/4. She doesn't have enough for 9 cakes. So you would still round down in that sense. So word problems don't necessarily follow the normal rules of rounding. Just throwing that out there. But they just said, how many can you make? Sure, you can make 1/4 of a cake. But if it was talking about like how many kids you could fit in a bus, can you fit 1/4 of a kid? Would they be happy if you sliced a kid into like a fourth? You sliced off an arm, crammed it in, and then you put the rest of the kid in another car. No, we only have enough room for 8 kids in this car. So think about the word problem. Is this a type of word problem where I can have fractional amounts as an answer? If it's money, yes. Things like this, yes. But if it's like talking about people and things, no, it has to be only whole numbers. Okay, again, just something always to think about when you're dealing with word problems. For my next problem, I'm adding a decimal. So what I like to do is, I know I have to line up my decimals, so I put my decimals underneath of each other, and then I have 15 to the left of it and 2 to the right of my decimal. And then, so I need 2 zero placement holders, and then I just add like normal. 5, 4, 4, bring down my decimal. 1 and 5 make 6, and bring down the 1. So you have 16.445. One thing that's helpful is kind of just estimate, like 1 and something plus 15 something should be 16 and something. So you should get 16 and something for your answer. Like if you accidentally don't line up your decimals correctly, estimating your decimal answers is a wise suggestion to make sure that your answer makes sense. Okay. For our next one, it says find the difference. So I'm subtracting, which means, yes, I still need to line up my decimals. So I'm going to line up my decimal there. The 3 went to the left of it, and 4, 3, 5 went to the right of it, 0 placement holder. Okay, 2 minus 0 is 2. You can't take 5 from 1, so borrow. And 11 minus 5 is 6. 4 minus 3 is 1. You can't take 4 from 3, so borrow. 13 minus 4 is 9. Bring down my decimal. 3 can't go in to 1, so borrow. And 11 minus 3 is 8. And bring down my 6, because 6 minus 0 is 6. So you have 68.9162. Okay, when I'm multiplying, I don't need to line up my decimal. I worry about my decimal at the end. I just multiply like normal. Okay, well, these ones actually are lined up, but they didn't need to be. Okay, now I always put the one with the most number of digits. So this has 1, 2, 3, 4 digits, and this has 1, 2 digits. Put the one with the most digits on top. Okay, and then I'm going to multiply the 3 times everything. 3 times 2, 3 times 7, 3 times 1, 3 times 8. So 3 times 2 is 6. 3 times 7 is 21. 3 times 1 is 3 plus 2 is 5. And 3 times 8 is 24. Now the 3 is all used up, so I'm going to move on to the 1, but it's in the tens place because remember I'm ignoring decimals till the end. So I need to put a 0 placement holder, so I start in the tens place. 1 times 2 is 2. 1 times 7 is 7. 1 times 1 is 1. 1 times 8 is 8. Okay, now add down. You have 6, 3, 12, 6, and 10. There was one number after the decimal there, one number after the decimal there, for a total of 2 numbers after the decimal needed for my answer. So it's 1062.36. Okay, remember, if you ever feel like you need more practice typing into Google, CUDA worksheet on multiplying decimals or on subtracting decimals or on dividing decimals with answers. And then they'll give you a bunch of different practice problems. You can try them. and then you can check your answers. Okay, so CUDA is a great place to get extra practice if you ever find you're missing these and you want more. Okay, you're dividing this by that. So whatever comes first is inside the house, and whatever comes second is outside the house. When you're dividing with decimals, we actually can't, because a decimal is like a fraction, and we can't divide by fractions. So I need to move it to get rid of the decimal. Okay, so then when I move it here, however many times I move it to get rid of it in the divisor, I need to move it the same number of times in the dividend. So now you have 4 into 15.2. Okay. Can 4 go into 1? No. Can it go into 15? Yes. 3 times. 3 times 4 is 12. Subtract that, you get 3. Bring down the 2. And 4 goes into 32 8 times. Now, the one thing that I recommend that I didn't do is I would have brought my decimal straight up from the get-go when I first started, because otherwise I might forget about it. Because 4 times 38 is not 15.2, right? But 4 times 3.8 is 15.2. So that decimal is very important. Okay. My next one says Heather had $10 when she went to Target. When she got home, she only had $6.23. How much did she spend at Target? Clearly, this is not me, Heather, because I would have spent much more than about $4-ish. So, when you spend money, you subtract it, right? So if this is how much I had left, I basically want to find the difference between these, and then that will tell me how much I actually spent. Okay, so $10 is like 10.00. Line up your decimals, and then the 6 goes under here, and the 23 cents goes under there. However, you can't take 3 from 0, so I need to borrow. And since there was nothing there, I need to borrow again. And then there's nothing there, so borrow one last time. Now that can be a 10. 10 minus 3 is 7. 9 minus 2 is 7. Bring down your decimal. 9 minus 6 is 3. And 0 minus 0 is 0. So you have $3.77 that she spent. So that's why she has $6.23 left, because those added together equal the $10 that she started with. Okay, again, please be trying these problems first. So pause, try them, then unpause it and check it. It says a scale model of a tower was 2.53 feet tall. The actual tower is 42.1 times larger than the scale model. How tall is the actual tower? So it doesn't matter which one you put on top, because they both have 3 digits. So I'm just going to put 2.53 times 42.1. Okay, now again, when you're multiplying, you don't need to worry about lining up your decimals. That's only when you're adding and subtracting. So I have 3 times 1 is 3, 1 times 5 is 5, and 1 times 2 is 2. So that's all used up. I'm moving on to the number in the tens place, so I need to put a 0 placement holder, so now I start in the tens place. 2 times 3 is 6, 2 times 5 is 10, 2 times 2 is 4, plus 1 is 5. That's all used up, so now I'm starting in the hundreds place. So this time I'm going to put 2 placement holders so that I start in the hundreds place. 4 times 3 is 12. 4 times 5 is 20, plus 1 is 21. 4 times 2 is 8, plus 2 is 10. Add down, you have 3, 11. 4 plus 1 is 5, 6, 0, 1. There's 2 numbers after the decimal, 1 number after the decimal, for a total of 3 numbers needed after the decimal. So if it started as 2.53 and it's 42 times larger, it's 106.513 times larger. Or sorry, not larger. It is actually 106.513 feet tall. Okay, the next one says 1 container of craft paint covers 1.1 square yards. Jillian has to paint the top surface of 3 pieces of wood for her craft project. Okay, so she has to paint 3 pieces of wood. One piece is 0.4 square yards, the second piece is 1.55 square yards, and the last piece is 1.35 square yards. How many containers of paint are needed for her project? So first of all, I need to find the total amount that she needs to paint. and they told me that it's 0.4 or 1.55 and 1.35. Okay, so let's add all those together. And that's 10, 10, 13, and 3. Okay, so 3.3 square yards is how much she needs to cover. And it says one container only covers 1.1. Okay, what are you thinking? So this is the total amount that I need to cover. This is how much is required for just one, so I need to divide it in. Now you can't divide by decimals, so move it, and however many times you move it here, move it here. 11 goes into 33 3 times. So 3 cans of paint. All right. A marathon runner was running at a rate of 9.3 miles per hour. At that rate, how many hours will it take for the runner to run 26.2 miles? Round your answer to the nearest hundredth. Okay, what do you think? So, you have 9.3 miles in 1 hour, right? And you want to know how long it's going to take you. So how long will that take to go 26.2 miles? So what do you think you would do with that information? I think you would divide it, right? So I'm going to see, since it's 1 hour that it takes me to go that far, then let's see how many times that goes in. So I have 9.3 into 26.2. You can't divide by a decimal, so move it. And however many times I move it here, I need to move it there. So I have 93 into 262. Well, 93 cannot go into 2. It can't go into 26, but it can go into 262. So I asked myself, how many times is 9 going to 26? Not 3, so 2 times. That's 6 and 18. Subtract that. You get 76. 93 can't go into 76, but I'm done. So I'm going to add a decimal and a 0. Okay, there we go. And now I can bring down this next number. Okay, and 93 can go into 760. How many times? Well, 9 goes into 72 8 times, so let's try an 8. And that's 24. 72 plus 2 is 74. Okay. And then borrow. And you have 10 minus 4 is 6. 5 minus 4 is 1. And 7 minus 7 is 0. Okay. 16 is less than that, so I'm good to bring down my next number. 9 goes into 16 once. So 93. Borrow. 10 minus 3 is 7. Borrow. 15 minus 9 is 6. That's less than 93, so good to bring down the next number. And 93 goes into 670. 9 goes into 67. Let's see, 9 times 7 is 63. So 27, and then 63 plus 2 is 65. Borrow. 10 minus 7 is 3. 6 minus 5 is 1. 6 minus 6 is 0. 13 is less than 93. So you're good to bring down the next number to see how many times 93 goes into 130. However, it said round to the nearest hundredths. So that's 2 numbers after the decimal. So I only need to go 1 place further than the hundredths. If the number behind the one you're focusing on is 5 or above, it tells us to round up. If the number right here is 4 or below, then it tells us to stay whatever it was. Since it falls into the 5 or above category, it tells us 1 to round up to a 2. So it's 2.82 miles. Okay. Now, the next one says find the value of 9 squared. 9 squared means 9 times 9. So, because it's 9 times itself 2 times, this is the base. The exponent tells you how many times to multiply it by itself. And 9 times 9 is 81. So that was the value of it. All right, my next one says find the value of 28 to the 0. Well, anything to the 0 power is 1. And the reason for that is I'm going to do a much smaller number. Let's say 3. Okay. So you have 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 0. Okay. We know 3 squared is 3 times 3, which is 9. 3 times 3 times 3, well, 3 times 3 is 9, and 9 times 3 is 27. And 3 to the first just means 1 3, so a 3. Each time I move up, notice that I'm multiplying by a 3, right? 3 times 3 is 9. 9 times 3 is 27. So that means when you move back a step, you're dividing by 3. Well, 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Look, the 1 in the 0 spot is 1. Even if we did it like 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Okay, 2 times 2 is 4. 2 times 2 times 2 is 8. 1, 2 is a 2. Each time you move up, you're multiplying by that base of 2. So each time you back up a step, you're dividing by that base. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So anytime you get to the 0 step, it's always 1. That's why. So anything to the 0 power is 1. Again, just kind of write yourself that little reference. If you get to that and you forget, just do like a basic 2 or 3 and work your way forwards and backwards and look for the pattern, and then you'll be able to see it. Okay, and that trick will also help you in future years when it says to the negative 1, back up a step. What's 1 divided by 2? Haha. When you back up a step, what's 1 divided by 3? Look at that. And then 3 to the negative 2. 1/3 divided by 3 would be 1/9. And 1/2 divided by 1/2 would be 1/4. See how now it's going the opposite way? 2, 4, 8, 2, 4, 8, but it would just be in the denominators now. Okay, that's for future years. When that comes up, you can still use that trick to reference. Okay, write this expression using exponents. You have 4 to the 5th, and how many times does it appear? 3 times. Now, before you box this and say, yay, I'm done, this is not correct. This is saying 4 times itself 3 times all over 5. Again, what I currently have is saying this. That is not this. Once I put it in parentheses, this is saying, oh, 4/5 times 4/5 times 4/5. So yes, parentheses matter. Okay, the next one says write the expression 8 subtracted from, so I'm subtracting it from what? The product, so I'm multiplying 2 and some number. There we go. Write the expression 24 fewer than, so I'm subtracting 24 from what? Some number. Write the expression the quotient, I'm dividing. Whatever comes first is on top, and whatever comes second is on bottom. Write the expression of the sum of some number and 4.5. Okay, the next one says James is 2 years older than his sister Keisha. So James is 2 older than Keisha. If J represent James, yes, write an algebraic expression for Keisha's age. So I want to know Keisha's age. Okay, so Keisha would be, if he's older, that would mean that she's James minus 2, right? Because James is 2 older than her, so she's 2 years younger than James. And there we go. So that is an equation, and it said write an expression. There we go. Now it's an expression. So in terms of Keisha would be whatever James is minus 2. Okay, the next one says Kai wants to go to the fair and go on some rides. Write an expression on how much Kai will spend at the fair if admission into the fair costs $10 and each ride costs $3 each. Define your variable. Use a table to help you. Okay, so remember that like that per each every kind of tells me that it's the y per x. So each what? Each ride. So I know that I'm going to multiply 3 times the number of rides, and that's going to equal my answer of the cost, right? Or the y equals 3x. Okay, and that would be fine and dandy, except they said you also have this constant of $10 to get into the fair. Okay. If it's helpful, use a table. Okay. So the number of rides you go on and the cost to you. So if you go on 0 rides, you still have to pay $10 to get in. So no matter what, you have that plus 10. If you go on 1 ride, well, it was 1 times 3, so 3 plus the 10 to get in would be 13. If you go on 2 rides, well, 2 times 3 is 6, and 6 plus that 10 to get in is 16. Some people maybe saw this as a good starting point using a table. So then your expression would be however many rides you go on plus 10 is going to tell me the cost. Again, if it said equation, there you go. If it said expression, there we go. Okay, and for this one was tricky. Writing a table probably would have been helpful. So if you had done James and Keisha, okay, and I always identify James is 2 years older. So James is older, which makes her younger. Okay, so if he is like, let's say 5 versus 6 versus 7. Okay, so James is 2 older than Keisha. So if he's 5, she'd be 3. If he's 6, she'd be 4. If he's 7, she'd be 5. However old he is, what am I doing each time to Keisha? So they said use an expression and like to represent J for James. So I need to put a J here. So if James is just J, how do I represent Keisha using the J? Well, what do I do to here to get to here? Going in this direction, I always go minus 2. I take whatever this is and I subtract 2. If they had said, represent James in terms of Keisha, how do you move from here to here? You take whatever K is and you add 2. So K plus 2 would be James, but J minus 2 would be Keisha. Okay, again, using tables is helpful sometimes. Number 33. Micah always spends 3 times more studying than his sister Cass. So Micah always spends 3 times more. So Micah is more, she's less. Use this information to complete the table and write the algebraic expression for the time Micah spends studying if C represents how long Cass studies. Okay, so C for Cass. Okay, so less. And what is it? It's 3 times more. So if I'm going towards the more, I'm going to multiply by 3. So that would be 15. If I'm going towards the lesser one, I'm going to divide by 3. And 30 divided by 3 is 10. Okay, now I'm going again towards the more, so I'm going to multiply by 3 this time, and C times 3 is 3C. Okay, next one says find the prime factorization of 88. So break this down and keep going until you get to prime numbers. So what times what is 88? If your tree looks different than mine, that's okay, as long as we're all going to get to the same primes at the end. Okay, I said 8 times 11, and 8 can keep going to 2 and 4. 2 is done. 4 can keep going though to 2 and 2. Done, done. 11 is done. So now you have 2s and 11s. How many 2s? 1, 2, 3 2s. Double check. 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 11 is 88. That's what I started with. And these are only prime numbers that I'm dealing with. Perfect. Okay. My next one says that they want me to simplify the expression by using the distributive property. So I'm going to distribute the 6 to the x, bring down my sign, and then distribute the 6 to the 4. Well, 6 times x is 6x, minus 6 times 4 is 24. This has an x, this doesn't, so I can't combine them. I'm done. Okay, my next one. I again need to distribute. You have 8 times 3x plus 8 times that 4, but you also have that random 5x at the end and that random 12 at the beginning. So I can simplify 8 times 3x is 24x plus 8 times 4 is 32. Tack on the 5x and tack on that 12. Now for my like terms, I have a 24x and a 5x, and then these constants of 12 and 32. So I'm going to do the x's first. 24 plus 5 is 29x, plus 12 and 32 is 44. Okay, the next one says simplify the expression all the way to a single number. Now, a single number doesn't mean a single digit of like 1, 2, 3, etc. It just means like a single number, rather than leaving it as like 10 minus 3. Simplify that down to 7. Okay. All right. Inside of parentheses first, remember PEMDAS. So parentheses first, and within the parentheses, you still follow the order of operations. So do you add or multiply first? You multiply or divide first. So 2 times 3 is 6. And then I still need to simplify the parentheses. 4 plus 6 is 10. And then 10 squared is 100. And now that it's all subtracting, you just go from left to right. 101 minus 100 is 1. Bring down the minus 1, and 1 minus 1 is 0. Yep, all that work for 0. Okay, for this one, you want to simplify fractions, like simplify the numerator to a single number and simplify the denominator to a single number, and then do the top divided by the bottom. So here we have 4 plus 2 cubed is 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. Okay, and that's 12 over 6. And 12 divided by 6 is 2. Okay, so that whole thing simplified to 2. Now 5 times 2 is 10. Done. Okay, these next ones. My hint to you is that this is a single term divided by that single term plus that single term. So I would keep each of these things inside of brackets. So that way, like you do each of these first, because this represents a single number, 5 times m. You're going to take all that, divide it by this term of 2n plus this term. So 5 times m is a 6. Divided by 2 times n is a 5. Plus 3 times p is a 7. Okay, well, 5 times 6 is 30. Divided by 2 times 5 is 10. Plus 3 times 7 is 21. Now divide this. 30 divided by 10 is 3. And 3 plus 21 is 24. Done. Okay, my next one. This is a single term minus this divided by that. Okay, so 2 times e is 4 squared. Well, 4 squared is 16. 2 times 16 is 32. Okay. Now over here, you have 2 times f is 5 squared over 5 times g is 2. Okay, well on top, you have 5 squared first and 5 squared, because remember, exponents before multiplication. So exponent 25, so 2 times 25. And on bottom, 5 times 2 is 10. On top, 2 times 25 is 50 over 10. And 50 divided by 10 is 5. So you have 32 minus 5, which is 27. Done. Okay. If for some reason you struggled on a few of those, remember CUDA and type in like evaluating expressions into like CUDA worksheet on evaluating expressions into Google, and then you can get more practice on these guys. All right, next page says, which of the following expressions are equivalent? Show work and then circle the correct letters. So first off, I need to distribute 3 times x plus 3 times 5. Well, 3 times x is 3x plus 3 times 5 is 15. So 3x plus 15. The next one you have is 2x and 3x are like terms. So that makes 3x. Tack on the plus 15. Okay, here you have 2 times x is 2x plus 2 times 7 is 14 plus x. And 2x and x, 2x plus x is 3x plus 14. X's are 1, 2, 3, so 3 x's. And then my constants, 4 plus 5 is 9, 9 plus 6 is 15. Okay, so I have 3x plus 15 for this one, and this one, and that's my only random one. So those are the ones that are equivalent. Okay, the next one says solve and graph. Before you can graph, you have to get x by itself. So I'm going to do the inverse step of subtracting is to add 15. Whatever you do to one side, you do to the other. I do that because 15 minus 15 is 0. It cancels out, and I'm left with x by itself. And again, I could do that as long as I added 15 to this side as well. So that's 38. And then when I'm asked to graph it, the number bigger and smaller, and my dot is at 38. And yes, it's including that number. And it's not an inequality, so it's just that number right there. Okay, that's the only one that asked me to graph it. Now I'm just going to solve all these. The inverse of adding is to subtract. Those cancel because 15 minus 15 is 0. Bring down your h because h plus 0 is just h. Whatever you do to one side, you do to the other. So 16 minus 15 is 1. If you want to, you can always check, plug it back in. 1 plus 15 is 16. Okay. The inverse of multiplying, because when you have a number touching a variable, that means you're multiplying, is dividing. So I'm going to divide both sides by 14 because any number divided by itself is 1. And 1 times y is just y. Now you have 14 into 2, 24. 14 can't go into 2, but it can go into 22 once. Subtract that, and you get 8. Bring down the 4. 14 goes into 84. 8. No. 7. No. 6. Okay. So it goes in 16 times. Here, you are multiplying 3/8 times x, and the inverse of multiplying is to divide. But remember, like when you have 3/8 divided by 3/8, you go keep, change, flip, right? So dividing by 3/8 is the same as multiplying by its reciprocal. The reason we do that is because now the 8s can cross cancel to become 1, and the 3s can cross cancel to become 1. And now you have 1 times x, which is just x. Whatever you do to one side, you do to the other. Since I multiplied that side by 8 over 3, I need to multiply this side by 8 over 3. Now 3 can go into both. 3 divided by 3 is 1, and 24 divided by 3 is 8. So on top, 8 times 8 is 64, and on bottom, 1 times 1 is 1. 64 over 1 is 64. There's my answer. And for ones like this, since it's kind of messy, you definitely might want to plug 64 back in for x to check and make sure that it makes a true statement. Okay, here. Again, since we just learned, these are being multiplied. So the inverse of multiplying is to divide. And when you divide by a fraction, that's multiplying by its reciprocal. So instead of 1 over 2, it's 2 over 1, right? 1/2 divided by 1/2. Keep, change, flip. You multiplied it by its reciprocal. So those cancel and become 1, and those are already 1, and 1 times y is just y. I can do that as long as I do the same thing to the other side. Since I randomly multiplied this side by 2 over 1, multiply this side by 2 over 1, or just 2, right? And 6 times 2 is 12. Okay, tricky. When you're undoing these, it's in the reverse order of PEMDAS. So normally we do multiplication, division before addition and subtraction. But when you're doing it in the reverse order, that means I'm going to undo the addition or subtraction first. So those cancel. Whatever you do to one side, do to the other. And we have that. And 14 minus 8 is 6, and 8 minus 5 is 3. Bring down your 3r. Okay, and now I just need to get rid of that 3, which is being multiplied. So the inverse of multiplying is to divide. Well, 3 divided by 3 is 1. So you have 1r equals 36 divided by 3 is 12. Okay, for my next one, you have on top 3 plus 2 is 5 over 10 equals 4. And 5/10 is the same thing as 1/2. And now it looks kind of just like the problem up above. I'm going to multiply by the reciprocal of 2 over 1, or just 2, to get my x by itself, because those cancel, and I get just 1x. And 4 times 2 is 8. All right, we're moving right along. For my next one, it says determine which equations have a solution of x equals 6. Now, I strongly recommend that instead of trying to solve these, you just take whatever the x is and plug in a 6, and then solve them and see which ones make a true statement. Because sometimes we give you ones where x is negative, or where x is in the denominator, and you don't know how to do that, but you do know how to just plug 6 in and simplify. So I'm replacing all the x's with a 6 and seeing which ones make a true statement. 6 divided by 6 is 1, and 1 is equal to 1, true. 7 minus 6 is 1, bring down the equals 1, true statement. 1 equals 6 divided by 6 is 1, true statement. 1 plus 2 times 6 is 12, and 1 plus 12 is 13, which does not equal 27. So there you go. That's the only one that was not having 6 as your solution. Okay, my next one says Drew's pet cat lost 4.3 pounds last month and is now 9.55 pounds. How much did Drew's cat weigh? Write an equation using x to represent the original weight of the cat. Okay, the original weight. So we don't know how much the original weight was, but then he lost, so minus 4.3 pounds, and he's now equal to 9.55. Okay, so there's my equation. If they said, oh, I'm not asked to solve. They just said, write the equation, don't solve. Done. Okay. If you didn't put that one, another one you could have said is the original weight minus how much it is now is equal to how much it lost. Okay, that would work. Or some people might put the original weight is equal to how much it is now plus how much it lost. Or the original weight now is equal to how much it lost plus how much it is now. Okay, any of those four equations would work. It's just the first one's the one that makes the most sense to me. Okay, the next one says Wanda sells boxes of cookies for $5 per box. Yesterday, she earned $70. How many boxes of cookies did she sell? Write an equation using X to represent the number of cookie boxes she sold. So, Y per X. So, Y is the money. The rate is 5 times the number of cookie boxes. And they told me the money, so I'm going to replace the y with 70 equals 5x. Okay. So there's my equation. 5x equals 70, or 70 equals 5x. Now to solve it, I want to get y or x by itself. So the inverse of multiplying is to divide by 5. Those cancel. And 70 divided by 5 goes in once, 2, bring down the 0, 5 goes into 24 times, 14. So 14 boxes. And double check if that makes sense. 14 times 5 is 70. So yeah, he would have made $70. Okay, perfect. Write the ordered pair, quadrant, or axis of each point. Okay. So for this one, you have, remember x comma y is right if it's positive or left if it's negative, and y is up if it's positive or down if it's negative. Okay. So a goes left, so negative, and it goes left between 6 and 8, so that's -7, and then up 2. Okay, B goes to the right 1 and down 1. Again, please pause the video, try it yourself, and then unpause it and come back. Okay, C goes to the right 8 and up 6. D goes to the left 7 and down 9. E goes over nothing and down -7. And F goes to the right 4, up nothing. G goes to the left 1 and up 4. Okay, the last one says plot H at -2. So left 2, up 4. And there's an H. Okay, and then it also wanted me to identify the quadrant or axis. So this whole thing is called a C for coordinate plane. So then follow your C, 1, 2, 3, and 4. So A is in quadrant 2, B is in quadrant 4, C is in quadrant 1, E is on this line. Which line is that? The y-axis. D is down here in quadrant 3. F is here on this line, which is the x-axis. And G is again in quadrant 2. And H was in quadrant 2. Okay, 53 says write and graph an inequality. Max wants to make more than 15 an hour. So sometimes it's helpful to actually do the graph first. So we're dealing with the 15. It says he wants to make more than 15. So is that to the right or to the left? To the right. Is he happy if it's including 15 an hour, or does he just want more? He only wants more. Now, if it said 15 or more, then I would shade in the 15. Okay, so then the money I want to make is greater than 15. Remember, when you write the variable on the left, your arrowhead matches your inequality sign. If this was shaded in, it would be underlined because it's or equal to, it would be including that point. Okay, this one says, write and graph an inequality. Everything in the store was 99 cents or less. So 99 cents, and you have less and more. So 99 cents, including that point, or less. Less is going to the left. So how much it cost in terms of 99 cents is less than that, right? To the left, arrowhead matches your inequality, and it's underlined because it's including that point. We are just moving right along, aren't we? Hopefully you're getting most of these right. Okay, the next one says, answer the following questions based on the scenario. Jack saves $2 a week. What is the independent variable describing? So y per x. Okay, which one is what? My answer y depends upon what I did to the x. Or why did I get that answer? Well, it depends what I did to the x. Okay, so the independent is the x. That's the number of weeks. And my dependent is the y, which is the money, not $2. $2 is the rate because a variable can change, right? So what's changing? The total saved. And then again, double check it makes sense. How much I save depends upon how long I've been saving for. Yep. And then also the other thing, they kind of gave that to you when they gave you the table because X normally comes first. Like 99% of the time, X comes before the Y. So X was the number of weeks and Y was the total money saved. Okay, so let's do just easy numbers. 0, 1, 2, 3. So at times 0, he hasn't saved anything. But if he saves $2 a week, after 1 week, he'll have 2. After 2 weeks, he'll have 4. After 3 weeks, he'll have 6. So what's my equation? Y was always equal to whatever X was times 2. There you go. Or remember, your rate is usually multiplied by your X to give you your Y. Okay, use 55 to answer 56. Label the X and Y axis. So X was the number of weeks, and Y was the total money saved. And then I'm going to graph those points that we did. So over nothing, up nothing, over 1, up 2, over 2, up 4, and over 3, up 6. Remember, we can always use that rate to get to point as well. The rate is 2 or 2 over 1. So up 1, 2 over 1, 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 and so on. Like it keeps following that same line. If when you go to graph these points from your table, if one of them was like over here and you had to go off the line to get to it, you know you did something wrong because we're always dealing with linear equations, meaning they make a straight line and they move up at a constant rate. Okay, the next one says, McBurger earns $2 for every cheeseburger sold. What's the independent and what's the dependent? Well, why did I get that answer? It depends upon what I did to the X. And it's Y for every X. So X is the number of cheeseburgers and Y is the money. Not $2, but like how much McBurger is earning. Okay, so my equation would be y equals the rate of 2 times x, and there's no constant. Done. If McBurger sold 100 cheeseburgers, then how much money did they earn? So if this is my equation, it told me that they did 100 cheeseburgers. So the number of cheeseburgers is the x. So I'm going to plug 100 in for the x. Well, 2 times 100 is 200. So y is the money, so $200. Okay, if McBurger earned $60, so the amount earned is the y, so I'm going to plug 60 in for y to solve for x. To get x by itself, divide by 2. 60 divided by 2 is 30. Those cancel. So x is the number of burgers, so 30 burgers. Lucy goes to the fair. It costs $8 for admission and an additional $4 for each ride. Use C to represent how much money Lucy spent and R to represent the number of rides she went on. Okay, so you have, which one's your rate? This one. Remember, like per, each, every, that's normally your rate. So this is what's going to get multiplied by your x, right? And then y equals that. If there's a constant, we add that on. It's an additional $8 to get in. So if it said write it using y and x, there we go. But they said we want to use r and c. Well, what are you multiplying your rate times? It's 8 times each ride. So that is equal to the total cost. So if they tell you specific variables to use, then use those specific variables. If not, use y and x. And again, that hint can also tell you y for each x. So where x was, that's the rides, and where y was, that's the money, the cost. Okay, 59b says, if Lucy goes to the fair and goes on 12 rides, how much did she spend? Well, if we have the equation c equals 4r plus 8, and it says she went on 12 rides, plug 12 in for r, and 4 times 12 is 48, and that will give me the cost. Well, 48 plus 8 is 56. So it's going to cost $56 if she goes on 12 rides. Okay, for my next one, it says the numbers of gallons of gas purchased by 4 motorists. Here you go. Sorry, 1 second. Put that right here. Okay. The number of gallons of gas purchased by 4 motorists and the corresponding costs are plotted on the coordinate plane below. Which of these correctly shows the ratios of the different number of gallons of gas to their costs? Okay, so I'm basically going to look at this line that they gave me, and then I'm going to see which table has all the points on that line. So the first one says over 3, up 3. So over 3, up 3. Nope. Okay, over 3, up 1. Over 3, up 1 would be here. Nope. Okay, over 1, up 3. Yes. Over 2, up 6. Yes. Over 3, up 9. Yes. Over 4, up 12. Yes. And maybe it was a select all that apply. So let's double check. Over 1, up 1. Nope. Okay, there we go. So C is the only one that had these points on this line. My next one says, how many 1/6 pound hamburger patties can be made from a 8.5 pound package and a 9 2/3 pound package of ground beef? Explain your reasoning. So 1/6 pound patties, that's how much it requires to make. And I have an 8.5 pound and a 9 2/3 pounds amount of packages. So first of all, I'm going to combine how much I have. And both 2 and 3 can become 6, right? And 2 times what is 6? 3. So 1 times 3 is 3. 3 times what is 6? 2. So 2 times 2 is 4. 3 plus 4 is 7 over 6, and 8 plus 9 is 17. So that's 17 plus 6 goes into 7 once. Subtract that, you get 1. So put your remainder over what you divided by. 1 and 1 6 is the same as 7 6. So that's 18 and 1 6. So I have this total amount of meat, and it requires 1 6 to make each one. So I'm going to take my total amount and divide it by how much it requires for just one. So 18 times 6, 48. 6 plus 4 is 10. So 108 plus 1 is 109 over 6. Divided by 1 6. Keep. Change. Flip. That's actually much nicer than I was thinking. Those cross cancel and become 1. And 1 times 109 is 109 over 1. So just 109 hamburgers is how many I can make. So this is my final answer. They are going to, 1 point's going to be for showing your work. And then another point is going to be for justifying your reasoning. So explaining why you did what you did. So first I added the number of pounds in each package, the 8 1/2 and 9 2/3. And then I took that total amount and I divided it by the 1 6 needed to make each patty. So you're just telling what you did and like why you did it. And then some people, they did each amount. Like you have 8 1/2, you divided it by the 1 6, and the 9 2/3 and divided by 1 6. And then you took those two amounts and added them together. That's fine. That would have worked as well. I just think it's easier to do that one, but it's up to you. Okay. Both would have gotten you the same way. Just don't forget that it's 1 point for getting to the final answer, 1 point for showing your work, and 1 point for explaining why you did what you did. Okay. All right. We're almost done with this. You ready? Last page. I bet you thought this would never come. All right. It says, Georgette gave each of her grandchildren $53.75. If she gave a total of $322.50, how many grandchildren does Georgette have? Explain your reasoning. So if you take, let's see, she gave each of her grandchildren. So normally you would do like, this is the amount each get, and you'd multiply it by how many you have, and that equals the total money that like was given away. So to find how many she actually has, I would divide by 53.75. Oops. Okay. So 322.5 divided by 53.75. You can't divide by a decimal, so move it twice to get rid of it, which means I need to move it twice to get rid of it here. And when there's nothing there, you put a 0 placement holder. So you have 5375 into 32250. Okay. 5,000 cannot go into 332 or 322. It actually can't go into 3,000, but it can go into 32,000. Well, I know 5 goes into 32 about 6, so let's try 5,375 times 6. If it's too big, we'll try times 5. 42 plus 3 is 45. 18, 19, 20, 21, 22. 30 plus 2 is 32. And look at that. It goes in exactly perfectly even if I multiply by 6. So that means that she had 6 grandchildren. Okay, so you need to find out how many times 5375 can go into this amount to find out how many grandchildren there were. Okay, The last one says a grocery store sign indicates that apples are 8 for $2.40, and a sign by the oranges indicates that they are 6 for $4.40. Find the total cost of buying 3 apples and 3 oranges. Explain your reasoning. So, okay, first off, I need to find the cost per apple. So if it's $2.40 for 8 apples, let's divide by 8 to see how much it is for just one. Okay, because 8 divided by 8 is 1. So for one apple, well, how many times does 8 go into 240? I don't need to move the decimal because the number I'm dividing by doesn't have one. 8 can't go into 2, but it goes into 24 3 times. Okay, so 0.30. So it's 30 cents per apple. Now, we bought 3 apples, so if it's 30 cents for one times 3, 3 times 3 is 9, one number after the decimal, so there we go. So that's 90 cents for 3 apples. All right, then we need to find about oranges. Okay, well, the cost per orange, it was $4.50 for 6 oranges. So if you divide by 6, 6 divided by 6 is 1. So that'll be 1 orange. I need to figure out how many times 6 goes into 4.5. Let's see, that goes in 7. Bring down the 0, and 6 goes into 35 times. So 75 cents per orange. But how many oranges did you buy? It says you bought 3 oranges. So 75 cents times 3 of them is 15 plus 1. 21 plus 1 is 22. There's 2 numbers after the decimal. So $2.25 for 3 oranges. Now we want to find the total that we spent. So I need to go $2.25 plus 90 cents, which is $3.15 total. Okay, now if you had to define why you did what you did, just like justify each step. So you had to find the cost of each individual apple by dividing the cost by how many there were. So 2.4 by 8. Then you multiply that unit price, like what's the price of just one, 30 cents, with how many you bought. You bought 3. Okay, then you found the cost of each individual orange by finding the unit price. Okay, and then you multiplied that unit price of 75 cents with how many you bought of 3. And then you added the total amounts together, 90 cents and 225. And that told you the total that you spent. Okay. Congratulations, my little mathematicians. You have now mastered like half of the content for 6th grade. You should feel very, very proud of yourselves. I know that I do.